So we also have quite a few new people in the team. For those who don't know me, I'm Avram. I'm the team lead for the Ramen team, and today I will talk about micro-frontends. So yeah, when I put my son into bed, I'm telling him technical stories, so he fall asleep. Because what's better to talk about than technically to make someone fall asleep? But please don't during the brown bag. So yeah, let's get started. Once upon a time in the software land, there was a mythical monster. It was so huge that no developer alone was able to understand it. And it had everything. It had the presentation layer, the business logic, database access, mechanisms, configurations, everything. So feeding the monster was a very complex process, like deploying new features, and every component of it was very close related to the other. So it was very difficult to change it. So software engineers thought that let's at least separate the presentation layer from the everything else. And they came up with a new monster that they call client-server architecture. And the industry came up with new terms like Ninja front-end developer, Rockstar backend developer, and so on. And things seem to be a bit better for a while, but still the backend of the monster was huge and it had everything. So they thought, why don't we split even more? And we came up with a new architecture style and a new monster that we call service-oriented architecture. The idea was to split the business logic into logical domains and that have very clear boundaries. They do one thing, have teams focused on this one thing, and the idea was that it would be easier to build, maintain, and scale. In my example, these services communicate through a message bus. It can be something else. The main idea is to have to split your business around smaller services. And as it tends to happen in this industry, usually we exaggerate and we go to the other spectrum, or the end of the spectrum, microservices. And even thinner services, maybe they have maybe a bit different communication protocols, maybe through REST. But the point is that, again, we try to simplify things by splitting them up. But my talk is not about different architecture style, it's about micro-frontends. And yeah, when I said that to my son, he said, Dad, in all these architecture styles, it seems that the problem is on the backend. No one cares about the frontend. And I would say, look, Yanni, of course, there is someone who cares about the frontend, is the user. So let's blame the user. The user wants fast loading apps. They want apps that respond very quick to their inputs, that they work in cheap, low-end devices, and they want richer and richer experiences because they don't want to download yet another app from the store. So what software engineers thought was, okay, let's move things on the front end. Let's move more and more business logic to the front end. Let's do some data heavy lifting in the front end. So we interact as less as possible with the backend and have more interactive applications. And then my son asked me, but that now you have a monolith on the front end, don't you? And actually, that's correct. So what did we thought was, let's do the same on the front end. Let's split even things there as well. So the idea was to separate frontends as we did with the backends, have teams that are focused completely on one single thing, that they include all the people that need from the database till the browser, that they have everyone needed to implement a feature. They can ship independently, they can use whatever technology they want, and they have as less as possible cross-team dependencies. And to see an example, imagine that you're in a company and you have three teams. You have the product team that it owns the product listing page and the product details page. You have a payments team that has the payments page and the confirmation of the payment. And you have a landing pages team that just implements some marketing landing pages. So each team has its own area of expertise, have all the people that need for this area. They don't have overlapping mission, and they can develop their apps independently. Okay, that sounds cool. How would you do that? One example, simplest example, is with all plain links, no fancy integration technique. Every team builds an application independently. The contract between the teams is the URL. And for example, the product team has a product page with a buy button, which is and knows the URL of the payment page. The user clicks the buy button, goes to the payment page. The payments team knows the URL of the product, and has a button to return you back. So they don't have to care about programming languages, frameworks, styling approaches. They are independently, and this is the main benefit. They can even have different hosting solutions. But I mean, on the front end, you have things that are common. What about the header? What about the footer? All the common things that you have in a page. Will every team have to re-implement them? And that's a very good question. Another way to have micro-frontends is using iframes. This is what Spotify did in their first version of the client desktop application. The playlist was a different iframe. The sidebar where you see what your friends are listening is a different iframe. So what iframes do is they make it possible to integrate one page inside the other. So imagine that you have a landing page managed by the landing pages team, and you want to have a side bar with some products, but with the content coming from the payments team. You can reference, we have an HTML tag, iframe, reference this content. It works on every browser. It provides very strong isolation. They don't have scripts and style leaking around. It have very good security features, and it looks great, right? Yeah, my son told me that, yeah, other babies say very bad things about the iframes. Don't lie to me. Tell me all the drawbacks. So one major drawback is that the page that contains the iframe needs to know the height of it to not create scrolling overflows or white spaces. For example, in here, the landing pages team has to know the height of the content that the payments team will provide. Also, iframes create a separate browser context with its own memory and CPU usage, which obviously harms the performance. They break the semantics of the page. If you have screen readers that are not able to understand what's going on in the page, and they also harm the SEO because the search engines when you read a page with 2-3 different iframes, they see 2-3 different pages, and they are indexing them separately. But I wanted to focus a bit on the layout issue. As I said, you need to know the height, and imagine here that we have a landing page, an article, and here there is an iframe coming from the payments team. We have defined the height, and let's see how that loads. You have defined height, the content comes, the images are bigger than expected, and then you have this scrolling effect that is quite ugly as experience. Another way to implement iframe is using Ajax with fragments. So the payments team exposes an endpoint that you can call and get some markup. And the landing pages team just have to call this endpoint, take the content, and inject it into their page. Let's see it with a bit of code. So you have the landing pages team. Here you have a site, let's say, tag. You define there a fragment with a data attribute. This references the content provided by the products team. And then you go take this, you read this attribute, you take this URL, you fetch it, you convert the response to the actual text, and you insert it into the DOM. And this looks great, doesn't break any screen reader, doesn't break the SEO, but as my son pointed out, what about the styles and JavaScript isolation? If you don't have that, you need to, everything has to namespace somehow these things, and you load the fragment asynchronously. Isn't that bad? And yeah, it is bad. Let's see it with an example. Here, as you see, there is again the same article, and here we will load the fragment asynchronously. We don't have to know the height in that case, but what happens is that the page has loaded, the fragment comes, and you have this effect, which is pretty terrible, because if you imagine that this content was somewhere in the middle of the article, you have paragraphs jumping around. Why this is happening is because, yeah, as I said, you first load the page, and then the page has to load the fragment and creates this waterfall effect compared to iframes, for example, that everything is loaded in parallel. So we have these two solutions, and both of them have their really bad, really big drawbacks. And my son said to that, I have an idea. Why don't we just use server-side rendering? What does it mean, server-side rendering, in the context of a micro-frontends setup? Typically, the teams build their applications independently, and then there is a composition service that sits in front of these applications. It takes the fragments of every team, it composes the full page, and return it to the user complete. The benefit is that this has a very good SEO performance, and it's quite robust, because imagine if the products team endpoint is down, you can have some fallbacks and just still serve something to the user, but maybe without the products sidebar. How we can do that? One way to do it is through Nginx, and something that they have, which is called server-side includes, which basically a team has to include a comment. It's a comment HTML with some specific syntax referencing a URL. And Nginx will take this comment in call this URL, take the data and inject it into the final page and return it to the user. Let's see, for example, the user asks for the landing page, and Nginx calls the application of the landing pages team. This team returns back a markup. This markup has the tag, this server-side include special tag. Nginx will read that. It will go and fetch this fragment from the products team app and assemble the full page and return it back to the user. And to see it in the terms of loading time, the landing page loads, the Nginx loads the landing page, loads the fragment, and then start sending the page to the user. And there is a metric called time to first byte, which is quite critical. It's how fast you can send the first bytes to the user. So imagine if you have more fragments, even if it's a server-to-server communication, it can take quite some time. So someone said, why don't we start sending the data earlier without having to wait for these fragments? So in the web, there is something that is existing forever from the early days of web, that you can stream HTML to the browser. And that's the idea, is that you load the landing page, but as soon as you have it, you will start streaming it to the user. And then as you get more data, you will keep streaming chunks of data, chunks of HTML, but really fast to the browser. So the browser can start laying out the page. How we can do that? There is a standard called SE. For example, Varnish implements that. Varnish is an application accelerator. It's depending on how you see it, maybe. The idea is that the user requests the landing page. Varnish goes to the landing page team application, requests this page. This team returns a markup which has this special tag again. Varnish already starts streaming this data to the user, but in parallel goes and fetches the rest of the content from the products team app. Another way to do is what Zalando did. Zalando has different teams even for footer and header, and basically they had a project called Mosaic, and one component of this project was node server, node package called Taylor. So the teams defined in the markup the fragments, and then Taylor is responsible to, it's a service, responsible to go take all these fragments and start, they can take them in parallel, that's the cool thing, and they can start streaming the data to the browser. So how does it look like? Yeah, it's a node server or package that can be used with many servers like Express. We defined the views, you define the fragment, and then what they did is you can include styles and JavaScript in the headers of the responses, so they can even check that, okay, we already have loaded this asset, don't load it again. So yeah, the tools like Taylor, it's very good because you own the code, and you can do fancy stuff without, you don't depend on any server sitting in front of your applications. You can create fancy fallback mechanisms, and also the benefit is that you don't need, on the local development environment, you don't need to ask the developers to install Varnish or Nginx. About the SE and server-side include mechanisms. It's old, really old technologies, but that also it means that are very stable. And at the end of the day, it's up to what you as a team can support. If I have to say something is not that easy to reason about these services. I have quite bad experiences with Varnish, for example, on caching. It has cached some fragments. You don't know what's going on, and then yeah, it's quite tricky to debug. That's my personal experience, but yeah, maybe it's just me. Yeah, again, doesn't come with these techniques, does not come with technical isolation in the browser. You still have to, this thing have to rely on, for example, CSS class name prefixes to not have name collisions. And if you want to have something more interactive than serving what a server-side solution can provide you, you need to do some hydration in the front end and combine server-side techniques with client-side integration. Yeah, we have all these techniques, but at the end of the day, you need to communicate between pages or between fragments, and there are different ways to do that. This could be by its own separate brown bag. Just briefly to say that you can implement direct communication between fragments. Two teams agree and they say how would communicate, and you have some events that the other team is listening to. But this, at the end of the day, is breaking the isolation and the ability, the promise of being independent. You can have orchestration via a parent. For example, you have two fragments living in a page. The page should be responsible to coordinate the communication between these two fragments if needed. Ideally, it shouldn't. Or you can have an event bus. There is this broadcast API, only Safari, I think, doesn't implement it yet, that you can publish events and anyone from anywhere in the page can listen to them. Yeah, and because we use frameworks and we use, I don't know, Redux or MobX, whatever you may use, and it's very tempting to think about, oh, I want this data that the other team already has in that page, why I have to go and refetch it. That's true, you will probably have to refetch it, and there is probably one more round trip to do to the server, but it should be a different server, actually. The idea is that you sacrifice a bit of redundancy, let's say, and you have some duplicates in favor of having some isolation. So ideally, you shouldn't have any shared state between these applications that each team has developed. And you shouldn't have any communication with the backends of another team. I mean, it doesn't make sense to be isolated on the front end and then have you communicating with the backend of another team. Then you again create a coupling to the other team. But in the front end, there are things that you need to share at the end of the day. Maybe you have some analytics, maybe you have some metadata handling. There is some logic that it should be common and you shouldn't have to re-implement. And then there comes the idea of the application cell, which is a cell that inside which the pages of or the fragments of the teams go in. It's very important that you don't spoil this application shell with any business logic, because then again you create a coupling, and you shouldn't be depending, your deployment shouldn't depend on the application shell. It should be completely independent. Yeah, at the end of the day, micro-frontends are not any specific technology. It's more about the concepts of how you structure your teams and your code. If you have, for example, here if you have 3 applications and you have a team working on 2 of them and another team working on the same 2 of them, at the end of the day, you don't have any isolation. The teams have to be fully focused on one single application and that they own from end to end. The benefits is that, yeah, I mean, we already talked about the benefits. There are a few things, although that can be a few topics that are kind of shared, like continuous delivery, analytics, dashboards, all these things. Probably, I mean, you can do it independently, that's the benefit, but for these topics, maybe it's not a good idea to do them independently. Maybe it's a good idea to have a cross-team decision and to do exactly the same tools, exactly the same approaches on these topics. Yeah, again, it's not about the software, it's about the people. Spotify did this approach and they implemented something that they called guilds, that they share knowledge between the teams. It's a way, I think they already changed it, but it's a way that it's super important in this structure to share knowledge, so you're not completely blind on what the other teams are doing. And that's it from my side. I try to make it in a high level as possible because I thought that we'll have a second presentation. But yeah, if you have any question, let me know.
Avram, can you share the slides, please?
Yeah. Any question?
Hey, Avram, I have.
Yeah.
So first of all, thank you for the presentation. It's really great to have these kind of topics in these Brown Bank sessions. So yeah, it was really cool. Also the story, you know, with your kid and so on. So you put a lot of effort on it. So yeah, my question is, how do you think you will assure the same UX across all the micro frontends, for example?
Yeah, that's a good question. I mean, the companies who have go to this approach, first to say that this is, I mean, 95% of the time you don't need something like that. This is for really, probably for really big companies like Amazon, Zalando, that have 10 teams working on the front end, and they need this approach. But usually what happens with these teams is that with these companies, of course, they have a components library and they share, but what I have seen is that maybe you also have noticed it, that if you go to Amazon, you can see buttons that are completely different between pages. You go to one page and you have one kind of styling for the button, and then you go to another page and you have the button maybe slightly different because this team has not adapted yet the next version of the component library. So they are okay with that. They sacrifice this, I don't know, this consistency in favor of giving the teams the power to be independent.
So yeah, I agree with that. So if we want to transit this in Marlespoon, this will take like some time, right? Because we are not there now.
Yeah. And I'm not sure, honestly, if it would make sense at the end of the day, if you would need something like that. Maybe in 2 years, if the company offers too many products and you have too many landing pages, or I don't know. At the moment, personally, I don't see the need, but I mean, it's good to know about techniques and if the need comes up, be able to use it.
I have more questions, but I don't know if other people wants to ask as well, so I don't want to.
I have a small question, or maybe, yeah, kind of. you said it's not about software, it's more about organizing team, right? But does this, but is it possible to combine it with the progressive web apps, for example, where there is more a solid client that tasks to a server, but
I
as you
think
already...
progressive web apps come down to having a solid application cell. Maybe you need to have a dedicated team that handles this application cell, takes care of it. But I don't see any conflict between implementing progressive web apps and having a micro-frontends approach.
Mhm. But there's also no benefit in doing this, or do you think it would be...
I mean, it depends. Progressive web apps try to solve, I think, another problem. They don't try to solve the organization problem. As this approach, they try to solve the need to offer more like app-like experience in the mobile, but doesn't prevent you to combine the two things, I think.
Mhm. Thanks.
Cool. If we don't have other questions, maybe Max you can text me or you can write on our Slack channel.
All right, I have maybe just two
Yeah.
two more really quick. So with the micro-frontends, you can have like different technologies in each team. So do you know if these companies like Zalando or Amazon or these big companies, they use different technologies actually? And if so, like how would we handle the situation in which one developer says, okay, I don't want to be, or I have been working for 1 year in the the product team, and then now I want to go to the payments team, and they have totally different technologies, and then for the companies it's a cost, right?
Yeah, definitely. You have to be able to handle this cost that someone has to learn a new technology. But I also think that in these companies in their hiring pipeline, they don't focus on a specific framework. Let's say they are focusing more on skills in general, at least from my experience with Amazon, for example. But I cannot really, I'm not sure to answer. But as far as I know, for example, Zalando is doing that. They have, I'm not sure if it's in the main side or it's if one of their, for example, in Zalon or one of their other brands, that they have things that are part of the page is Vue and other page is React, and maybe have some legacy Angular pages. They do it.
Okay, cool. Thank you.
Thank you, guys. Thank you for your time.
Thank you, Avram.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye.